Good morning, friends. In this video, we will discuss about deviations from Beer Lambert law. At the end of this video, we have few questions related to this video. Factors contributing to deviations can be categorized into two types. They are spectral deviation and chemical deviation. Now we will discuss about spectral deviation. As we all know, requirement of Beer Lambert law is that the light incident on the sample should be monochromatic. Monochromatic light means light with narrow range of wavelengths. See, the light of spectral bandwidth less than one-tenth the natural bandwidth of the sample gives linear Beer-Lambert law graph. For example, a sample absorbs light from 510 nanometers to 720 nanometers. For example, a sample absorbs a light from 510 nanometers to 720 nanometers. Its natural bandwidth will become 720 nanometers minus 510 nanometers. That means we have to subtract the lower wavelength from the higher wavelength. That gives 210 nanometers. 210 nanometers is the natural bandwidth of that sample. So 1/10 of natural bandwidth means 210 by 10 nanometers, that equal to 21 nanometers. So for that sample, the monochromator with spectral bandwidth less than 21 nanometers has to be used. If we use the monochromator with spectral bandwidth more than 21 nanometers, uh, deviation from Beer-Lambert law occurs. So if the light incident is non-monochromatic light, the deviation from Beer-Lambert law occurs. And also presence of stray light will show deviation from Beer-Lambert law. Stray light arises due to scattering and refraction inside the monochromator, which is due to imperfections on the optical surfaces. Now we will discuss about chemical deviation. If sample undergoes chemical effects such as dissociation, association, polymerization or complex formation at various concentrations, then deviation from Beer-Lambert law occurs. For example, take a high concentrated solution of benzoic acid in unbuffered aqueous solution, that means for which this pH is not adjusted. Unbuffered aqueous solution has a lower pH and contains a higher proportion of unionized form. This is the unionized form of benzoic acid. This is the ionized form. These unionized and ionized forms have different absorption characteristics. We can see here lambda max for benzoic acid. Unionized form is 273 nanometers and whose molar absorptivity is 970. For ionized form, lambda max is 268 nanometers and molar absorptivity is 560. So change in concentration of benzoic acid causes deviation from Beer-Lambert law. So to obey Beer-Lambert law, the solutions used in UV visible spectrophotometer has to be for the solutions used in UV visible spectrophotometer, the pH is to be adjusted and also lower concentrations are to be used. Let's answer few questions related to this. First one, deviation from Beer-Lambert law occurs in cases of A. Higher concentrations, B. Stray light, C. Non-chromatic light, D. All the above. You can pause the video and guess the correct answer. The answer is all the above. All these causes deviation from Beer Lambert law. Second one, spectral bandwidth of light should be less than dash the natural bandwidth of the sample to give linear Beer Lambert law graph. A 110, B 128, C 100, D none of the above. Answer is 110. The natural bandwidth, spectral bandwidth of light should be less than 1/10 the natural bandwidth of the sample. Same we are applying here in this question. Uh, if a sample absorbs light from 510 nanometers to 720 nanometers with lambda max at 620 nanometers, its natural bandwidth is A 620 minus 510 nanometers, B 720 minus 510 nanometers, C 720 plus 510 nanometers, D none of the above. The correct answer is B 720 minus 510 nanometers. We have to subtract lower wavelength from higher wavelength to get the natural bandwidth of that sample. That is 210 nanometers will be the answer. Thank you for watching. Please like, share and subscribe for more.